Ladies and gentlemen, please welcome to the stage a representative from Forterra.
All right, I got a home crowd here. All right. Got a clicker.
Gotta initiate it, and then now it should work. If you hit it.
I can probably just do it.
Yeah, you gotta like press it hard.
There's a video. All right, sorry. So we had a video, but that's all right. I can talk through this. So just quick introduction. My name is Paul Benfield. I'm the head of strategy at Forterra. Forterra builds ground autonomy. Just as a way of a quick background, I did a little over 20 years in the Army. Relevant to this event, I was lucky enough to serve in the Pentagon with both Ash Carter and Bob Work when they were leading a lot of this innovation and offset endeavors that have led this event. Ely Baratari, Ilber Baratari, very good friends of mine. It's kind of amazing to see how far SESP has brought this event and the Expo and the Ash Carter Exchange. So just really an honor and a privilege to be here. What we're going to talk about today is the imperative of ground autonomy, future battlefields, what Forterra does, how we do it, and then I'll give a little bit of a demo at the end of our TerraLink user interface, which is how we manage fleets of vehicles. So the strategic imperative. I believe we are losing credible deterrence, especially in the Indo-Pacific. I think our adversaries believe we no longer have the scale or the mass to win a conflict. The reason I think they believe that is because we no longer have the scale or the mass to win in a conflict. The Department of Defense is focused on very exquisite, very complex platforms that are very expensive. We believe the future is cheaper, attritable, more scalable platforms. This is not a nice to have, it's a strategic imperative. We cannot compete platform to platform against, say, potential adversaries in the Pacific. We'll get costed out, priced out of the conflict before it even starts. So how do you make platforms less expensive? You remove some of the survivability requirements. Why would you remove survivability requirements? Because there's no people around them, right? Let those vehicles, let those platforms do missions autonomously. Even if we have that mass of platforms now on the battlefield, it's very hard to project them into theater, right? And so even if we had them, how do we get them to the fight? Our theory of the case is a large number of attritable systems that do a myriad of missions, forward deployed, maybe pre-positioned, that can be operated from beyond line of sight. So let's walk through a notional sort of OpCon scenario, right? Imagine an infantry platoon of soldiers or Marines on an island operating from a fairly secure, fairly remote dispersed position. Call that the front line of troops. In front of that infantry, say platoon, is a front line of robots with EW, offensive cyber, early warning, maybe counter-AS, space defense. All of those systems basically becoming a tripwire for adversaries. That human-machine formation, say infantry size, operating under the umbrella of larger systems that are also unmanned. Anti-ship missiles, Patriots, ATACMS. So that force can now operate safely underneath an umbrella of systems that have much longer range, much longer reach, much more lethality. Well, that's great that you have all those soldiers and Marines out there operating safely. How do you resupply them? There's no reason why logistics from the operational to the strategic level shouldn't be automated. Shouldn't be unmanned, shouldn't be operated from a safe position, again, beyond line of sight. So from tactical resupply all the way back to strategic resupply, we're talking the home front. If you create this notional operational concept, what you've created is multiple dilemmas for the adversary. We have just flipped the cost curve onto our adversaries where they have to spend expensive munitions to kill less expensive platforms. That's even if they solve the targeting problem. Imagine these systems dispersed across multiple island chains, across broad geography. Now they have a targeting problem that makes, again, we're trying to create horns of a dilemma, trying to make sure that we have as much deterrence as possible so that they realize it is a little bit too difficult to go tonight. Maybe we have to wait till tomorrow. So how do we do this? Forterra does not drive vehicles. Forterra drives the mission. We do that through a complete autonomy ecosystem with software, ruggedized hardware, and mission planning. We are integrating payloads and platforms to close missions. You have to do that with a tightly coupled hardware and software stack that is replicable, that is easily replicable, so you can get to scale. My hot take is platforms are irrelevant. Platforms have one purpose for existing, and that is to move a payload within range to do a thing. And so once you start thinking of the payload as the primary mission set and the platform as a commodity, once you remove the humans and now you don't have the expensive survivability costs, you can really get to low-cost, attritable systems that close missions. We are platform agnostic, we are payload agnostic, we move payload to where they need to be autonomously. Because we are agnostic, we have been able to integrate our system on a multitude of platforms, which means we can get to scale. We can produce at scale. What does that look like? So Forterra is the only vendor that is involved in every single ground autonomy program in DoD. We have the Nemesis Rogue Fires platform, which is a Marine Corps system that has anti-ship missiles on a cabless JLTV body. Again, let's go back to operational concepts. Imagine a whole bunch of these systems scattered around island chains that can be positioned, repositioned, and moved autonomously beyond line of sight. Once they fire, they can rapidly reposition to avoid counter battery. That becomes a very powerful deterrent in terms of sea control if you have these things hidden all over island chains. Anybody in the Defense Department that was there about 10 years ago knows how hard it was to find North Korean launchers moving around that peninsula. We want to give the Chinese the same problem. We are operating anti-ship missiles on large vehicles. We are operating counter-UAS systems on small tactical vehicles. We are operating commercial all-terrain vehicles. We are operating palletized load system, PLS truck cargo vehicles. Forterra is producing at scale. We also have commercial. The important thing about this, so our commercial offering, we do port facilities, logging trucks, mining vehicles, anything that's sort of on public off-road conveyances, private conveyances, not public roads. Two things about this. One, our stack is the same that we use commercial or government. We have the same hardware software stack for both. As we scale out our commercial business, that's going to drive the cost down for DoD. The other thing is a lot of the missions for the commercial logistics are the exact same analogous to military operations. So we talked about the strategic imperative. We talked about what Forterra does. This is how we do it. So I'm going to talk auto drive first, and then I'll talk TerraLink. So auto drive, this is our software stack. We've got perception, that is 4D, LiDAR, EO/IR cameras, state-of-the-art sensors, commercial off-the-shelf, all US built, that determine what is around the vehicle. This is the vehicle seeing what is around it in space. For localization, we use GPS, but also inertial navigation systems that allow the vehicle to know where it is in the world without GPS. So we can go GPS denied, even subterranean, and still operate. Perception and localization, they get married to behavior generation. How does the vehicle operate on the ground, on the terrain? And we are focused on very difficult, very dynamic terrain, not pre-mapped routes, cross-country, or dirt roads, trees falling in front, new obstacles that were unplanned for. The vehicle can dynamically pick the best route, move around obstacles, and get to the most efficient pathway. For the behavior generation then gets translated into vehicle control, right? How the vehicle actually uses the actuators, the steering, the braking, the reverse. All of that lives inside of our auto drive box. That is the compute box that we build in-house that holds all of these AI ML models to allow all of that to happen. The comms, very redundant comms, secure or commercial cell, SATCOM, including Starlink, Mannet radio, microwave. We have a stack of comm suite that can operate very well in comms contested environments. So I want to highlight the fact that this very tightly coupled hardware and software stack, I said it before, I'm going to repeat it, is easily replicable regardless of the platform, regardless of the dimensions of the vehicle, regardless if it's a small tactical robot or a large commercial logistics vehicle. This is about scale. Ilbert opened the remarks this morning about the test question for this conference is, are you delivering? Enough of the valley of death, enough of S&T, enough of testing, are you delivering? Not only is Forterra delivering, this is how we're delivering it. The Marine Corps Nemesis program is going to have 400 systems out. They are in production right now. We are building dozens of Polaris commercial Rangers to do mobility, counter-mobility operations with Army combat engineers. This is not PowerPoint. This is not a science project. This should be fielded at scale today. There's no reason why it can't be. All right, now getting into TerraLink. TerraLink is our single pane of glass, completely API agnostic, desktop, remote, ATAC, whatever third-party system. If you have your own commercial warehouse system, we can tie into that. But what this allows is situation awareness, mission planning, and vehicle telemetry coming back to the operator. The intent of TerraLink is the intent of most UX. It's got to be intuitive, right? Think of yourself as a 19-year-old soldier Marine. If you don't understand how to operate in 15 minutes, it's probably not helpful for you. It's got to be intuitive. It's got to reduce cognitive load so that the operator can supervise multiple platforms instead of a single person, eyes down, operating one vehicle. So with that, I think, okay, so we're starting with a world view. We're going to drill down into one particular vehicle. This is an SMET, and this is going to kind of go on in the background, but I just want to talk through the value of a UX that is very intuitive. You can manipulate feeds, you can manipulate your own data stream, so what you see is the operator changing the view as they need for this mission set. You can see some telemetry data down on the bottom. You can pull all of the very top left, you see that's the the LiDAR feedback coming and the path that it's generating and moving across. All of that LiDAR data comes back to make the models even more effective as we keep doing iterations. All of this is completely, modular. It is completely fungible. The user can design this however they see fit for whatever mission set they're using. I'll talk one quick con-op that happened recently where two soldiers in a Polaris all-terrain vehicle had two of these SMETs driving behind them. They get to an objective rally point. Once at the ORP, soldier pulls down an ATAC, puts a point on the map for SMET 1, go do this observation mission. Puts a point on a map on the ATAC, observation point 2, go do this observation mission. While those vehicles are going to their observation points, the soldiers in that vehicle in a safe, secure position, couple terrain features away, are now looking at the broader battlefield, getting tasks from higher, coordinating with adjacent units. They are not actively maneuvering those vehicles, removing that cognitive load so they can go to higher order tasks. As that vehicle, the manned vehicle started to exfil, they passed control of the 2 robots back to the CP, even further back to the rear. Said, hey, I'm busy right now, I'm gonna start exfilling, you have control of the robots. As they hit a certain point, that CP said, all right, robots, now follow back in on the convoy. And as soon as they hit a certain certain point on the map, those 2 vehicles autonomously and robotically fell into the path, following that vehicle all the way home. That is just one of hundreds of potential use cases you can use, but we actually did that with the Army not very long ago. In a minute, we're going to jump over to the commercial stuff, but the value of a UX that anyone can use in about 10 minutes of training and get all of that telemetry data, that's important, but I also want to foot stomp the cognitive load, removing cognitive load from soldiers so they can do higher order tasks. All right, now we're going to jump into some of our commercial stuff. This is warehouse docking. This is going to seem boring, which is exactly what we're looking for. This is consistent, this is safe, this is reliable, and this is actually more effective than human drivers. What we'll highlight here is, in terms of national security, Forterra is not ignorant of the fact that logistics doesn't end on the battlefield. Logistics starts in the homeland, strategic ports, strategic facilities, warehouses. How are you going to tie end-to-end all the logistics chain to get equipment from the home front to the tactical edge? And how we have our third example of Army palletized load system trucks, commonly referred to as PLS trucks. So think from that warehouse out to the front edge. What you've got here is either leader-follower, you have a manned vehicle in the front. Trail vehicles are maintaining a certain distance, a certain rate of speed behind that vehicle, or completely autonomous. It's completely mission dependent, commander's choice, whatever the requirements on the ground are. You can do waypoint, where you drop waypoints along like breadcrumbs that it follows. You can do pre-mapped. You can do leader-follower. You can do completely autonomous. This mission set, we're not trying to remove humans from the battlefield. We're trying to allow humans to do more with what they have. So a human on the battlefield can now have more scale, have more reach, be more effective, be more lethal. The last thing I'll show is a Polaris ATV, and you'll see here in a second waypoint movement. So you'll see the operator actually manipulating waypoints because it wants it to go in a specific route, and that vehicle can follow that route. So what I wanted to highlight with this quick demo is you have seen multiple vehicle platforms conduct multiple types of missions under multiple modalities with a single UX that is very intuitive, that an operator can move from one individual manually controlling a vehicle to one operator supervising multiple vehicles conducting multiple missions. With that, I know I didn't hit 30 minutes, so I'm just going to stand up here and filibuster. And no. With that, I think I'm going to close it out, give everybody some time to go grab some coffee. I will stay up here on the side. If anybody has questions, happy to entertain questions up here. And with that, thank you for your time.